a furnace wall is made up of 3 layers of thickness. So there are 3 layers. This is the total cross section of the wall. There will be 3 layers. One of thickness 250, then 100, and another of 150. So let us call this material as ABC. Then they are having conductivities 1.65 K and 9.2. So 1.65 K and 9.2 are the conductivities. The inside surface, let this be the inside surface of the wall, and this is exposed to gases at 125 degrees Celsius, and this inner surface temperature is also given. In this particular question, temperature is given, that is 1100 degrees Celsius. And heat transfer, so from gas there will be heat transferred to this surface because the temperature of the surface is less than that of gases. So that is through convection. So convection coefficient is given as 25. Then the outside temperature is 25, and there will also be some convection from this wall to air. So that convection also it is given as 12. The transfer coefficient is given as 12. So the basic thing is first Q, let Q be the heat that is going from this gas to this particular surface. So that Q is equal to HI. HI means this inside heat transfer coefficient into delta T. Delta T is the temperature difference of this surface, that is T1 and Ti. Ti minus T1. So that will be the heat transferred from this gas to this surface, inside surface. Then there is material A, and through this material A, the same amount of heat that is transferred from gas to this wall, that is Q, passes through material A, then it passes through material B, then it passes through material C, and at last it comes out. The same heat Q comes out because of convection. So Q is equal to HITi minus T1, that is the amount that is transferred through the inside wall because of convection. Then the heat transferred from this through this substance A, that is from this T1 to temperature T2, that can be found out K into dt by dx. dt means temperature difference between the walls of this material A. So that is equal to Ka. K is conductivity of the material into T1 minus T2 by L, length of that particular one. So we will get heat Q. Then that heat will now it is going to enter to B. Again heat through B. Q is equal to Kb into T2 minus T3 by length 0.1. Similarly through C, T3 minus T4 by. So we will get heat. At last here heat comes and it will be convected out. So Q is equal to HO, that is outside convection coefficient into T4 minus TO. So these all are, we are separately considering the heat, first passing through this one, then through A, through B, through C, like that. Or we can find the heat if we know the inside the temperature and outside temperature, then we can find some by something like this. Here it is Ti minus To, inside temperature by outside temperature, divided by 1 by H1, that is the resistance because of this one, this convection, and then La by Ka, resistance because of A, Lb by Kb, resistance because of C, and Lc by Kc, resistance because of C. Then at last, because of this convection, there is some during this convection there is some resistance. So now here it is Ti and To we know on 250 and 250. Hm we know it is 25. LA we know, but LB we know, but KB is not given. LC KC we know and H1. So we can substitute all those things, but we do not know KB. But Q we can find by using this equation, because here T1 we know, T2, T3, T4 are unknown. That means this equation we can't use. But Ti and T1 are known. So we can substitute, that is 1250 and 1100 here. And Hi is now 25. Inference, we can find Q, and that Q can be substituted here to find this K. So in total, we should remember these equations. So as slab increases or decreases, either one of them will disappear or one more time will be get get added. But anyway, we should know that there are some basic equation like this. All these equations are equal, q q q q q. So any one of the equation will help us to find this q. Now we have some overall q, something like in some question TA will be given, T0 will be given, LA will be, everything will be. So we will get q from this equation. We can get q from this equation. Then here q is given, h1 is given, so maybe t1 is not given, so we can find t1. So if we have t1, we can substitute and find t2, then t3, t4. So all temperatures can be founded by using each of these equations. So first what we want to do is, here suppose that q is found out by this equation, or here q we are obtaining from this equation, that q can be substituted here. Then h0 is known, t outside is known, so we can find t4. That t4 can be substituted here, q we already know. So again t3 can be found, again t3 is substituted here, t2, like that we can find the wall temperature. This is how we make use of this composite wall techniques to find temperatures and all.